What we have here is an example of a mass calculation in stoichiometry, and this one comes from page 237, problem number 57. It says when lead ore, lead 2 sulfide, burns in oxygen, the products are solid lead oxide and sulfur dioxide gas. And we want to write out the balanced equation, and then we have a couple of questions. Now anytime we do any sort of stoichiometry, we absolutely have got to have a balanced equation. So let's go ahead and do that. So we have lead oxide, which is lead 2 sulfide, and we can start out like this. And we got to decide what we're going to do here. It burns in oxygen. Remember, oxygen is always a diatomic, and it's going to produce lead oxide plus sulfur dioxide. Okay, there we go. We can verify this is correct because sulfur generally has a -2 charge, and this is lead 2, so we know that's a +2. So sure enough, the correct charges are on here. Oxygen is always a diatomic when it's found by itself, and once again we look over here and that's lead 2 oxide, and oxygen is usually a -2, and sulfur dioxide. So it looks like we have the correct form here. This is not like lead with a subscript 2 or anything like that. It's just PbS and PbO over here. And so now we need to balance this guy, and it looks like, let's see, we got one lead over here, we got one lead over here, we got one sulfur, and we got 3 oxygens over here. So why don't we just go ahead and balance out like this. We'll say 2 leads, and the reason why I said 2 leads is because we got an odd number of oxygens to begin with, and that's an even number of oxygens. So we go 2 leads, so that'll give us 2 over here, and that means we'll have to have 2 sulfurs over there to balance out this sulfur, 2 sulfurs. And now we have 2 oxygens there, 4 oxygens there, that makes 6, and so we need a 3 over here, and I believe that's balanced. So let's go ahead and check it. We got 2 leads, 2 leads, 2 sulfurs, 2 sulfurs, 6 oxygens, there's 2, there's another 4 right there, that makes 6 oxygens, so sure enough that's balanced. Now the next thing we're asked is how many grams of oxygen are required to react with 29.9 grams of lead 2 sulfide. So we got 29.9 grams lead sulfide, and we want to know how many grams of oxygen is going to react with that. Okay, so we should set it up like this. Grams of A, you can get moles of A. We'll use our mole ratio of what we want over what we started with, and that'll give us moles of B. And then finally, once we have moles of B, we can get grams of B. Now we started out with 29.9 grams of lead sulfide, and we want to know how many grams of oxygen do we need. And so we'll follow this, and our A is lead sulfide and our B is oxygen. So 29.9 grams lead sulfide, and we need the molecular weight of lead sulfide, and we look at our periodic chart and we find lead is right there at 207.2, so it's 207.2 plus a sulfur, which is 32.1. So the molecular weight of lead sulfide is 239.3 grams per mole. So that would be a mole is 239.3 grams. And our mole ratio would be the mole ratio of our oxygen to our lead sulfide. So oxygen to lead sulfide is 3 to 2. And so that's 3 oxygens for every 2 lead sulfides. And then finally we need to multiply out by the molecular weight of oxygen. Remember, those are 2 oxygens, so that makes 32, not 16. So that's 32 grams per mole oxygen. And we're done with that part. All we have to do is put it in our calculator, and we would have 29.9 times 3 times 32 divided by parentheses 239.3 times 2 close parentheses equals, and I get 5.997 or 6.00 grams of oxygen. So now we move on to C, and it says how many grams of sulfur dioxide can be produced when 65.0 grams of lead-2 sulfide reacts. So we have 65.0 grams of lead sulfide, and we want to know how many grams of sulfur dioxide are we going to get. So we'll go ahead and multiply this out again, and it will be moles lead sulfide for every 239.3 grams, and we need the mole ratio of sulfur dioxide, which would be 2 sulfur dioxides for every 2 lead sulfides. And then finally we need the molecular weight of sulfur dioxide, and that's 32 plus 32. 32 is the atomic mass of sulfur, and 32 is the mass of 2 oxygen, so that's 64.0 grams sulfur dioxide for every mole sulfur dioxide. And we're done. Just need to plug it in our calculator, and we go 65 times 2 times 64 divided by parentheses 239.3 times 2 close parentheses, and I get 17.4 grams of sulfur dioxide. Finally, we have part D. How many grams of lead-2 sulfide are used to produce 128 grams of lead-2 oxide? And so we have 128 grams lead oxide. That's what we produced, and we need to know the molecular weight for the lead oxide first, and it is 207 plus 16, which would be 223.2. So a mole of lead oxide is 223.2 grams. We need the mole ratio of lead oxide to lead sulfide, so it's 2 lead oxides, 2 lead sulfides for every 2 lead oxides. And then finally we need to know the molecular weight for lead sulfur, or lead sulfide, lead-2 sulfide, and it is 207.2 plus 32.1, and I get 239.3 grams lead sulfide for every mole lead sulfide. And we just need to put it in our calculator, and so I get 128 times 2 times 239.3 divided by parentheses 223.2 times 2 close parentheses, and I get 137 grams lead sulfide. And that's how many grams of lead sulfide you need to produce 128 grams of lead oxide.